Thank you for the introduction. So, my name is Gwénaëlle Proust. I'm actually got a promotion since I submitted, so I'm now the director of the Cine Manufacturing Hub, but that's only recent. And I'm here to present this capability that is available at the University of Sydney. Yes. So, the first thing is we are part of a bigger entity that's called the Core Research Facility at the University of Sydney. So what that means is that we are not part of any faculty or any school. We are directly dependent on the DVC research. And so that means that we are here to serve everybody on campus the same way. There's no like preferential for one school, one faculty, or anything. Those core research facilities are here to serve everybody on campus. So as you can see, there are 8 different research facilities. We are the last one because we are the newest one, although I'm not sure this is done chronologically because the first one was a Sydney microscopy and macroanalysis. And as you can see, most of these research facilities have grown from collaboration, or since then collaboration, with some industry, which is also the case for the Sydney Manufacturing Hub. As Sam mentioned previously in his talk, we have started this facility in collaboration with GE Additive. We also have a second partner, Third Axis, which is a local company, and they are working mostly in ceramics. With GE, we're doing mostly metal. And the way we collaborate with Third Axis is that they actually purchase additive manufacturing equipment, and we host this equipment in our facility, and we share the time on it, roughly 50-50, although we're not measuring every minute, but that's the idea. And the engineers in our facility are maintaining the equipment, and we're sharing the cost of maintenance and consumables. So here is a Sydney Manufacturing Hub. So we are still relatively small team. So as I say, I'm the academic director. In the audience today with us is also Bruce Macklin, who's our chief engineer. So at the end of this talk, if you have any question for technological question, I will recommend to go talk to our chief engineer, Bruce. If you have any question about how to collaborate with us or any academic question, please come to see me. Or you can see any of us, and we always communicate between us. At the moment, we have 2 senior staff engineers, and we are actually in the process of hiring 2 new staff engineers, so the team is going to grow soon. So what do we do? So the idea of the Sydney Manufacturing Hub came to Simon Ringer, who's my boss, and the director of the Core Research Facility, thinking that actually at the University of Sydney, we had nothing to make things in bulk. We didn't have the capacity, and we had a lot of material researchers and mechanical engineer researcher, and we had no way that we could do things in bulk processing. So this is how this capability was started, and basically the idea was to be able to produce any type of material, metals, ceramics, polymers, composites, and to focus on additive manufacturing, but also to have a full workflow, go from the design, making the part, to the heat treatment or the post-processing that needs to be done after the part is manufactured. And we have also some equipment to do some characterization to verify what we are producing, either the shape or the surface roughness of the final product. So we're trying to have a complete workflow with some design software to the characterization at the end. And because we are also part of the Core Research Facility, we have also access through the other core research facility to microstructure characterization, for example, material characterization, and so on and so forth. So we talk a lot about additive manufacturing today, and I just wanted for people who might not be familiar, we've talked mostly about two types of additive manufacturing this morning. We talk about material extrusion, which was actually the previous talk. We were talking about the polymer with the screw, the extrusion, and then the deposition. And we talk also about powder bed fusion with several talks, and especially the one from Sam. But there is actually 7 at this point techniques that have been recognized as additive manufacturing. And our goal at the Sydney Manufacturing Hub is to help people, researchers, industry, to figure out which one is the one that you need for your application. Because there is not one technique that is going to do it all. It's going to be depending on the final application, on the material that you're going to use, on the money you want to spend. There is a lot of different parameters that's going to dictate what is the additive manufacturing technology that's going to be appropriate. And we do not have, at the moment, all these different technology available in our lab, but we are working towards building our capability. So for the moment, for the moment, we have material extrusion, powder bed fusion, and vat polymerization at technique already available in our lab. And we're working to get more of this technique available for our users. So a bit of a time frame. So here I started this, Here, I'll get it. Here I started the story in Q1 2020, but the story is older than that. This started in 2018 with some discussion between GE and Simon Ringer, and there was a lot of things to be done. In 2019, I was part of an effort at the university to design the lab space that we were going to transform for our new Sydney Manufacturing Hub and see what type of equipment we will relocate from other labs and what type of equipment we should purchase as a priority. And in December 2019, we were given the key of our facility. And in Q1 2020, we opened the Sydney Manufacturing Hub with the arrival of the first equipment, which was actually the machine that Third Axis has purchased, which is a ceramic printer. As you know, Q1 2020 was also the start of the pandemic in Australia, so it was not the best time to start a lab, and as you might imagine, it took us a bit longer to get everything we had ordered or we wanted inside, and so we had to close a few times during 2020 and 2021, as most people at the universities. But what you see is that still in 2020, we got our first GE metal printer, the M Lab. We got then some polymer printer that were actually relocated from a previous lab I own. And then in Q1 2021, we got our other GE metal printer. So here everything is color-coded in function of the application. So you see that we have in blue all that's polymer additive, in yellow what is ceramic additive, in pink what is metal additive, in light gray is our heat treatment, and in green is our characterization equipment. So you see that we are here at the moment, and actually a couple of weeks ago was a nice week for us. We got a lot more equipment in our lab. We got our arc melter delivered, and we got I forgot to put them. We got more printer for polymers. So we have plans for the future to grow. You see it's coming to 2024. So we already know that we're going to purchase a 3D scanner, a chemical characterization, new FDM printer to do high printing and high resolution resin. Oh, here the high resolution resin, they're already here actually. And high temperature FDM printers. At the end of this year or start of the next year, we're going to go into solid state additive manufacturing as well with 2 new equipment that are going to be coming to a facility. And we also looking to go to micron resolution polymer printers and to get a HIP. So all that, as you see, is LEAF grant. So we submitted to ARC LEAF grant this year to get new equipment. So how do we decide what to put next in our facilities, depending on the demand, but also on the evolution of the technology, what's happening in people who are downstairs showing the new type of equipment that they've developed. But we're also working with our researcher at the university to see what are their needs, and we want to work more with industry to see what we could do to help them. So current state of Sydney manufacturing hub. So as I said, we have powder bed fusion, either with laser or electron beams, to do metal additive manufacturing. At the moment, we can do titanium alloy, nickel superalloy, stainless steel, a few stainless steel, aluminum alloys, copper, bronze. But this is not limiting ourselves. We can do more things if there is an interest from our users or future users. In metal extrusion, we're doing fuse deposition modeling, and we're also doing some paste extrusion, where we can do any material that can be clay, porcelain, concrete, as well. In vat polymerization, this is a technology for our ceramic and bioresorbable ceramics printer. And we have also a high resolution resin printer that comes with a similar process. And as I said, we have pre and post processing software, equipment, and analytical support. So here is just a short video to show a bit of what we look like. Okay, so this was a show of what we have, and this is our laboratory and some of our staff. And here is just a reminder of what is our mission. So we are part of a university, so our first mission is to support research that's going on at the University of Sydney. That's why the DVCR spent some money to create, firstly, this place. So we have, at the moment, users in the Faculty of Engineering, Faculty of Health and Medicine, Faculty of Science. We even had some people from the arts faculty coming to see us, to see that we can do some arts with additive manufacturing as well. And we also supporting researchers in other institutions. We are working with some researchers at UNSW at the moment, and we're looking forward to work also with other universities and researchers if they have a need for this facility. So this is our first mission. And in that mission, we have also different roles. Like we can look at developing technology or developing material. My background is material science. I'm a material scientist, so I'm interested in understanding how the process changes the microstructure of material and how we can tailor microstructure to get certain properties. But everybody doesn't do that, and some people just want to have one part printed for an experiment, and we're also doing that. And the other role that we have, because we have a manufacturing, we are doing manufacturing, this is directly related to industry. We cannot do manufacturing if we don't have any idea of how is that going to help the economy and the manufacturing in Australia. So we want to work with industry. And the way we see ourselves is, oops. Here I draw this little table. Actually, my collaborator Bruce drew this little table that I thought was really explicit. So we talk about the technical readiness level previously in different talks. And we see ourselves, the Cine Manufacturing Hub, as working towards meeting TRL 1, 2, 3. And I'm not saying we're only going to do that, because it's always going to be dependent on the application, the material, and the industry. We can push it a bit further. But we see ourselves as TRL 1, 2, 3. We want to do technology research and proof of concept. We see, and I hope I'm not off the mark here, is we see the Australian the Advanced Manufacturing Research Facility that is about to be created as the logical step after us, which is going to go to TRL 4 to 6, maybe 7, maybe 8. Once again, I'm not limiting, not to say that they're never going to be 1 to 3. But I see that more as going towards the final goal of a final product. And then logically, this will be then taken on board by SMEs to go to the final TRLs that you have a product and it can be delivered. And once again, I know some industry are also working on TRL 1 and 3 and 4 to 7. Once again, this is just an idea of what can be done, but they can be moving things around. And one thing is important is that we are already here. So this is coming in 2023. This is going to be fantastic, new facilities, new things. But in the meantime, we are already operating. So if you have any interest to try to explore what can be done with advanced manufacturing and additive manufacturing in a range of material, please come talk to us. Okay, so example of projects supported by SMH. So as I said, we started in 2020. There were a lot of things happening, not many people on campus for 6 months out of 2 years. We didn't do as much as we would like, but we have managed to have some really interesting projects that are still ongoing, that started a few months ago or some a year ago, and that's still ongoing. So this first one that I'm mentioning, which is direct air capture, is a project that is led by a professor in chemistry, so Faculty of Science, Professor Diana D'Alessandro. And she's working with some industry partner, Southern Green Gas, and the objective is to address the urgent need for negative emission. So they want to create DSC, so direct air capture cartridge, that will contain nanomaterial that they're producing in their lab in chemistry, which are metallic organic frameworks, or called MOFs. If you ever went around this acronym, that's what it means. And this material will selectively remove CO2 from the air. But they need to be able to put that somewhere. What they're creating is a paste, and this needs a support. So they reach out to us, and I cannot show you the design because this is industry related, but they come up with a design, and they work with one of our engineers to optimize the design and create the design in a polymer. And using different 3D printing polymers that we have in our laboratory, they are able now to experiment with creating the cartridge on which they're going to coat after with the MOFs. And then here is an example. Oops, this is counterintuitive. They're going to do some experiments. They're going to have the device inside here, and they're going to put some CO2 in it and see how much is absorbed. And the idea is that, sorry, I have to stop turning, but it's difficult. They're going to have this system that is going to be powered by solar energy. So it's going to be a sustainable, self-working system that's going to be able to reduce the amount of CO2 in the air. And so they would not have been able to do that without us because they didn't have the knowledge or the facility or the capability to create those devices. And so they came to us, and we've been working together now for a few months. And I just got actually just an email this morning from Diana. She got another grant. So we're going to be able to continue the project and do more work with them. Another project that we are working at SMH with researchers at the University of Sydney, and this is actually our first project that started in 2020 and that we keep working with an iteration. So this project is done by a PhD student, Jacinta Cleary, and it's part of a big project which is called the Bionic Eye. But basically, they want to restore the capability for people to blink once they might have had a stroke or anything that makes that now their eyes is not blinking, the lid is not closing, and this is an issue because you don't get water in your eye and it gets dry. So they want to have this device done. So this device, there's a lot of component into it, as you might imagine. The idea is that it's going to be put inside your skull, and so they need to have, there's going to be electronic, there's going to be a lot of things, but what they wanted to do is that where we put that once again. So they've been working in making these components here, and there's a bit more inside actually, that are going to be the encapsulation for the device. And they already tested that on chip. They already printed several of these devices, optimized the shape, optimized the property, and then they've been trying this device now on chip until they can move on to the next, the target. So there are other projects that are ongoing. So we have a few. So they have myself a few projects where I work on materials mostly and understanding, for example, how we can upcycle the wood industry byproducts. When you have sawdust, what do you do with the sawdust? It's a pretty useless material. You can put that in glue, but there's not much to be done. So we're trying to see, can we recycle that at the same time as we recycle polymers to make wood plastic composites? And I work on that project with my collaborator Sandra Lashka from architecture, and we're trying to not only make the material, improve the property, but also work on the design of the component that it actually does look like wood at the end. Simon is working in collaboration with Sodaxis to do 3D printing of advanced ceramic and characterizing the property. We have project with additive where we're looking at recycling the powder that are used in powder bed to make sure that you can have as much use out of them before you have to discard them. And we are looking, at point of view of the powder property themselves. And then we have project with people in AMME, Assad Masri, where we're looking at creating catalytic combustion devices for them. And so on and so forth. I didn't do the entire list, but just to see the diversity of working in materials, working on the process itself, or working on making better component. So now here, we are here to talk with industry more, and how can we collaborate with industry? So there is different way industry can work with the Cine Manufacturing Hub. You can do commission research and development project where you have an idea and you just want to test it, and you going to hire us basically to try to produce whatever you wanted to produce. You can also just come, and get usage or training of the equipment, or we can then do also research collaborations through grant applications. So this morning you already mentioned CRCPs that are going to be a way for university and industry to collaborate and to get a contribution from the government, or RSA linkages. So we are already working with industry. I'm not saying we're not. We have, for example, we have some work with Romar. We are working with GE and Third Axis. We also done some project for PackServe, which is a company that's working in packaging, and they wanted to do a new component using additive manufacturing, and they were quite happy with the results. So we just want to try to increase our collaboration with industry and to see how we can help industry adopt faster advanced manufacturing, or additive manufacturing in this case, in the production line. So there is something that actually going to happen in that area. We are leading a few events in advanced manufacturing. So the first one I should mention is that the University of Sydney and SMH are directly collaborating with COE, a company, that is organizing Modern Manufacturing Expo in September. So we're going to also try to reach out to industry to talk more about modern manufacturing. We're going to create an initiative in digital science around manufacturing, advanced manufacturing and materials, with the idea to create some large group, so other university will be involved to try to see if we can create later a center of research on digital science and additive or advanced manufacturing. So all these things are coming, and there will be more news on our website, which, by the way, this is where you can find some more information. The best way is to Google Sydney Manufacturing Hub. Don't do SMH because they bring you to Sydney Morning Herald, so you won't find us. So type Sydney Manufacturing Hub, and you will see on this web page we have the list of all the equipment that is available, the charge for using the equipment, or contact information, and so on and so forth. And Bruce and I will be here for the rest of the day. If you have any question, please don't hesitate to come and talk to us. And that's it, sorry. Yeah.